Afternoon, everybody, and welcome to this session of the Healthcare Analytics Conference. This is a Targeting Advancing Analytics stream. My name is Sean Rowick. I'm Associate Director, Healthcare Data Analytics at the National Institute for Health and Care Excellence, or NICE, as we like to be called, and I'll be chairing this session. So a few quick housekeeping points that you're probably all aware of by now. So please use the Q&A to submit your questions at any time. You can upvote questions you're most interested in. You can, comment in the chat for reflections and discussion points. You can also view the speaker bios and connect with speakers in the People tab. And also you can kind of take notes within the platform directly. So in the interest of time, I'll get on with things and introduce our first speaker for this session, which is Chris Bealey. He's Head of Data Science at the Strategy Unit, and his talk is titled Multidisciplinary Analytical Pipelines, Productionising a Business Critical Simulation Model. So over to you, Chris. You've got about 25 minutes, including questions as well.
Great, thank you very much. If you could please add my slides, Claire, that'd be good. Thank you very much. Right, hello everyone. It's nice to be back. Feeling slightly less pressure doing this talk than I have been in the backstage doing all the complicated admin stuff. So basically, this presentation is all about building a simulation model, as my team and I have been engaged in doing for about two years-ish. I think that doing it well required a lot of collaboration from a lot of different staff, not just data science. There's all kinds of different staff, analytical and non-analytical, with lots of different skill sets. I do think a lot of this stuff around the modeling is not obvious. And so that's why I want to talk about some of it today. So I think it's one of the things I think that's nice about HACA is that, we can sort of dig in a little bit, and we don't just talk about regression lines. We can also just talk about some of the stuff that kind of sits around the analysis and kind of how to get from A to B in that sense. So that's what would like to talk about. So the new hospital program came to the strategy unit roughly in the year 2020. And the exam question was to predict demand in acute hospitals roughly in the year 2041, varying slightly, but that kind of range. There was existing work and knowledge in the strategy unit. There was obviously literature on this as well. And so the model was built on those foundations. I was not here when this project was conceived. My team only existed in the kind of data sciencey bit. So I can't take blame or credit for that bit, but those are the origins. I've just realised that rather unhelpfully I forgot to set a timer, but never mind. I need to remember 5 to 3. Right. So I just want to talk a little bit about kind of how we've done it, because I think we've done it based on our beliefs to a large degree, and I think that's really important. So we in the strategy unit think that predictive models should, as far as possible, be probabilistic. We don't think it makes sense when there's so much uncertainty about the future to give point estimates, because they will, be wrong. Predictions are usually wrong, but point estimates will be even more wronger, if you like. We think that analytical work should be transparent and open source. People who've heard me speak for more than about 10 minutes will no doubt have heard me say the word open source before. I think it's really important. I think it's partly what HACA is about. But I think in this case, we are talking essentially about modelling work that feeds into a variety of processes that build billion-pound hospitals. And so personally, I think it's an absolute no-brainer that the analysis, the foundations of that analysis should be, transparent and in the public record. That's not happening enough elsewhere. That's a different talk for me to bang on about, but that's one of the things that we believe. It was done in a collaborative way. My colleague Karen and I spoke about that a little bit yesterday. I'm not going to go into too much detail about that because Karen spoke about it very eloquently yesterday. But essentially, it's not about modeling to people. It's about modeling with them, listening to them, understanding their assumptions, understanding the way that they view the world. We think that results should be reproducible, which is very much in line with the sort of open source and transparency arguments. Again, because we're building billion-pound hospitals, I think the need for that is even greater. And we think that modelling should be done as far as possible, as far as is sensible, by the NHS and for the NHS. I think too often our sort of analytical futures are held in the hands of companies and individuals that don't necessarily have a kind of public benefit ethos. And I think that's a real shame. And I think the NHS can really, get on the front foot and start to own more of these things in the way that we've done. It did win an award. There's a link to more details about that on the slides, which I'll share somehow at some point. They're not currently viewable, I'm afraid. I haven't quite published them yet, but they will be. I'm on the wrong window. There we go. So what does the model do? So I'm going to be a little bit brief about this because I want to talk about a wide range of different things. But essentially, the model considers various types of things that you might expect to either increase or decrease hospital activity. Those include demographic change. So we expect in the future there will be more people, and those people will be older. And that would lead you to believe that there will be more activity happening in hospital. There's something else called non-demographic change, which for me is definitely a contender in the worst named thing ever, because it's just everything that's left after demographic change. It essentially has no meaning, really. But examples of that tend to be things like we invent new ways of doing things. We invent new things we couldn't do before. Patients, quite rightly, want more care. They want a better experience. There's just this sort of relentless march of healthcare activity and healthcare technology, which clearly is a good thing. And it's one of the marvelous benefits and something that I've certainly benefited a great deal over the last decade. But it does obviously tend to mean that our hospitals will be busier. And then something else that we call types of potentially mitigable activity, so-called left shift. So that is all sorts of different things. If fewer people smoke, there wouldn't be so much things in hospitals going on to do with people smoking. If we had good or better care pathways around frail and elderly, there might be differences with falls, all that kind of thing, all comes under that. One of the important parts of this work, I think, is that we've sort of tried to kind of codify and document those, as I say, openly and reproducibly and transparently in a way that will allow other people to understand what we've done and to reuse it. And there are other modeling components as well that we'd like to build on in the future. The model is a simulation model. It's a Monte Carlo simulation. So essentially what we do, there's loads of parameters, as described on the previous slide. They are all parameterized. We assume that the parameters will be normal because it's just easier. We might do something a bit cleverer one day, but we haven't yet. And we calculate demand within that hospital at various different slices of data, obviously things like inpatients, outpatients, A&E. We do this for 256 times. Sampling the parameters differently each time, and we plot the distribution. One of the nice things about the model is that the results come out conceptually at row level. I'm not going to overdo this because I don't really have time. But what that means essentially is that we take a year's worth of data and we take those individual rows and we either multiply them up or down depending on who that person is, how old they are, what's wrong with them, all that kind of thing. Do we think there'll be more people like this in the future, or do we think there'll be fewer? And that's a kind of multiplicative effect of all the things that grow it and all the things that shrink it. And we use Poisson sampling. So obviously you don't get 0.3 of the patient because that doesn't make any sense. In practice, what comes out of the model actually is not row level because that would melt the server. But we can slice it in different ways. And we have done that. We have been asked, well, how does it look if you slice like this? How do you look if you slice like this? And we can add that into the model. So that's a very kind of quick canter through the kind of some of the concepts of it. From a data science point of view, I'm not going to do one of the classic things that people do where they show you a huge diagram and they say, I'm sorry for this diagram, because there's really no point because it won't make any sense to you and it'd be too small and confusing on the screen. But there is one if you want one. There is a link in the slide. Basically, there are three places where we do stuff. And there's a variety of reasons why stuff happens in different places. And it's partly to do with information governance. So we store and process the data in a kind of secure CSU provisioned Azure. We did used to use SQL. The data pipelines take literally 4 days to run in SQL. And that can be extremely difficult if you're tinkering with them. So we actually use Databricks now, and it's very whizzy and cool. Please don't ask me to explain Databricks because I will fail. But my team use it very knowledgeably and very brilliantly. and the compute is handled with a Docker container. So we host the results and the dashboards and the reports and all that separately on a different server. That server it's not an open server, but it's connected to the internet, so people can see it, hospitals and such like. So we don't keep any data on it because obviously it might be a bad idea. And we obviously have lots of, a plethora, as you'd expect, of notebooks, scripts, bits of, ephemera on laptops. I do think we do a really good job actually of tidying those up occasionally and, making them really clear and consistent and reusable. But those are the kind of three main places where this is all going on. So one of the big challenges of doing this has been in versioning. So we've been developing the model for some time now, for pretty much 2 years, or more than 2 years, in fact. And we don't want to stop developing the model because we want to keep improving it, but we also don't want to stop other people's, we don't want to kind of have old models not work or become out of date or become difficult to use. So we've learned an incredible amount. I always wish I could get in a time machine, but I'm sure we all do. We've learned an incredible amount about how to do that. Well, I say we, as my brilliant team have learned that. Simply, the question really for us is, are we Apple or are we Microsoft? And what that means is there's the Apple way of doing things, where you just upgrade everyone's operating system and say, I'm sorry, halfway software doesn't work, tough luck kind of thing. And there's the Microsoft, we will support your, Windows XP for nuclear submarines, running on a remote island until, the year 2057. At the moment, I would say we are Microsoft, and that is quite challenging. And I think we'd like to be more Apple, and we're trying to figure out what's a responsible, sensible way of doing that. Particularly versioning of data is very difficult. We do want to be able to reproduce these results and allow people to make sense of them in the future because people are building billion-and-a-half hospitals with them. But it is not easy to improve this thing and keep on using it at the same time. That's not a simple thing to do. Something else that's not simple is using RAP, reproducible analytical pipelines. Of course, they're awesome. Of course, we all think that. But I think it's just interesting to reflect, actually, that they have at times slowed us down quite a lot. And I really buy into that slowdown and I really believe in it. But I think it's just worth kind of being honest and being aware of it. So we had something the other day, millions of rows of data, millions of rows, and one of them was wrong. We had basically a row of data that was wrong. And the exam question is, take out that row of data. Now, obviously, in the bad old days, I would have just bust out my spreadsheet and just pressed Control minus, and it's gone. But of course, that's a really bad idea because you'll never be able to find it again, and you don't remember that you did that. But applying a RAP approach to that actually is quite hard, and it took a bit of a go. So I just think this project's a really interesting example. I mean, not very often RAP will save you time 99.99999% of the time, but actually just occasionally it can be tricky. I just thought that was an interesting reflection. Some of the challenges we faced along the way, well, all models are wrong, we all know that. But it's, you can argue about, well, which kind of wrong do we want? You end up in that kind of situation. People have different types of wrong. People value different types of wrong differently depending on who they are. There's a real thing about consistency. So one of the real benefits, I think, of using this model is that it is something that is consistently applied across, those hospitals that are using it. It has a defined set of, SQL, and, there are ways of using this in a consistent way. But actually, there are good reasons to say, well, actually, this hospital is different because of this or that or the other. And managing that process between trying to have a really well-defined set of ways of doing something, but allowing people to meaningfully vary from it is challenging. It's difficult to make predictions, especially about the future. We all know that one as well. The truth is we don't know what's going to happen. One of the quotes that I really enjoy about this model is, the model is simple. That's from one of my team, Tom. What he means by that basically is this model will just do whatever stupid thing you tell it to do. It's a very clear example of that. If you put things into this model that are correct about the future, it will tell you the future very precisely. If you feed it nonsense, it will talk nonsense. And that's really challenging. People want it to do more, but that certainty is not there. It reminds me a little bit actually of what Jess was saying yesterday. Is AI is not magic, and neither is this. This model will tell you whatever you believe, basically, but in a kind of reliably, statistically kind of informed way. Essentially, that's what it's doing. One of the ways that we got around that was we asked experts. I'm not going to linger on this for too long because I don't really have time. It's a whole other talk, really. This was Professor Mohammed in the strategy unit, but basically we built some WYSI data science tool and we asked people, what do you think will happen in the future? And we collated what they believed, and we show that to hospitals to help them to understand what might happen for them. And it's very understanding, frail care pathways in your area. That's a very localized thing. A civil servant in Whitehall can't come along and tell you that. They don't know, and nor should they. We've had a lot of challenges about understanding people as users. I have got another talk a bit later on, actually, where I'm going to use the word users a lot. But essentially, who is using this model and what do they want? It seems like an obvious, it seems like a basic question, but the more you think about it, the perspectives multiply, and they are still multiplying, and that's really challenging. And coming up with structured ways of thinking about that, I think, has been a big benefit to this thing, something that held us back, but I think something that we're really building on. Decision making. I don't know. I guess this talk is partly, maybe as many of my talks are, they're sort of letters to the past from myself to myself. Again, it feels a little trivial but it really isn't. Making decisions in this kind of environment is very, very difficult. So you've got very, very kind of theoretical ideas about the way that data is kind of provisioned and, sliced and defined. And you've got very, very boots on the ground, pragmatic interpretations from analysts and from hospitals. And they're very different, and that's really challenging. And it's all being delivered with data science. So you can well come up with something that you want to happen, but sometimes I go to the team and say, oh, this, and they say, well, that doesn't, that's not possible, or it would take a computer 1,000 years, or, whatever it might be. There is just lots of fingers in the pie, and that's obviously a good thing. But it can be difficult to kind of to navigate that. I think we still have a challenge with openness and transparency, something I really believe in. I will die on this hill. You don't often hear that said literally, do you? I think, but it's hard. So we have open source all the code, but in order to run it, you need a copy of HES for one, but actually you need quite a lot of kind of tooling, and it's not something that's simple to do. And me and the team take that really seriously, and we do want to do our due diligence and be good citizens. But I think the big problem is I never get a Teams call at 9 a.m. saying, quick, Chris, share the model. That's not something that generates urgent action. And so it's something that we want to keep going on. Information governance, obviously, always is a trap. I won't linger on that again in the interest of time. Right, my final slide, bang on time. Just wanted to talk about kind of where we're going with it, really. So we started with a model that was designed to be run by a hospital, and it's worked pretty well so far, I would say, although we're still learning, as I've mentioned. We've already run it at national level, and we're starting to look more about how we could look at acute activity in a whole region. I think that lots of interest in that. A bring your own data model would be wonderful. I'd love to do that. I think it may be a future for FDP. I am supposed to be getting to grips with that at the moment and will be soon. That would release a lot of the IG problems. I think that would be a real benefit, but I don't currently know whether that's possible because I haven't really got to grips with it. And again, whenever I say I haven't got to grips with it, I mean my brilliant team haven't got to grips with it. We're still trying to understand more about these categories of potentially emittable activity that I mentioned. Are there more of them? Are there fewer of them? Are they well defined? There's all kinds of questions to be asked about that. And I think, yes, this whole business, obviously, we've been hearing today and other times, understanding, the shift from the hospital community. How will it happen? Why does it matter? Where is that going to go? All of these questions all feed into that. And I think there's lots of interesting analytical work to be done along those lines. So thank you very much. I will now stop talking.
Thanks, Chris. Thanks very much. Can you hear me okay?
Yes.
No, Chris. Oh, great. Okay. Yeah, that was really, really great talk, and really interesting, and well done sticking to time as well. I can't see any questions in the Q&A at the moment, so I'll use my kind of chair's prerogative to ask the question. So I guess you were talking through really interesting point you made about the Apple versus Microsoft model, really. So I was like wondering, do you have like a sense of of the scale of the problem of using the Microsoft model of that kind of continued support forever, and the kind of headaches that causes you?
Yeah, I mean, I think the biggest problem, I'm sure my team will be shouting at the screen because I'll probably get this wrong, but as my understanding is, the biggest problem we have is with data. So a, a, a lot of the way that we've versioned data up till now has been to have a copy of that data, because that's a really reliable and sensible way of versioning data. But you end up with more and more and more data. So I think we're slightly fighting a battle at the moment, to make sure that we have, we can reproduce what we've done, but without just kind of accreting more and more and more data. To that point as well, I think the other thing is people. So we're kind of custodian. I mean, I always tell people don't make me the custodian, but I don't know how seriously people take that. We're actually custodians of lots of parameters. So people have run lots of models. They've run models to iterate. They've run models to answer questions. They've run models for business cases. It's not a one and done process running these models, and nor should it be. There's scenario analysis, all that kind of stuff that goes into modeling. And again, so we're sort of accreting parameters. Now, those parameters that's not a computational. It's not going to fill a hard drive because I'm just talking about parameters. But how can we kind of work with them to make sure that they keep the ones that they want, or they understand what they've got and all that kind of stuff. As I say, don't really want to be the guy holding the keys to building all these £1 billion hospitals, because if I lose those keys or if I get them in the wrong place, it's not really my job. But nonetheless, putting that to one side, putting the kind of real business critical stuff to one side, how can we help people understand what they've gone and where they've, understand the scenarios that they've built and all that kind of stuff. And we are currently working on tooling to do that.
Brilliant, thank you. I can't see any other questions, but I suppose in the chat, I guess there's just been some acknowledgement of a really great presentation. I suppose kind of a half question in terms of how you protect your time without trying to be forced to move on to the next project, and how would you address those challenges, and do you have those?
Um, yes, I mean this project has a lot of steam, so I don't think that is a direct problem for us. I think the allied problem though is how do you separate kind of operational work versus strategic work? So as I say, we are building a model for the future. We are building a model that does different things, answers questions in different ways. We're building features for people. But also we have people who have a meeting at 10:30 a.m. and want to check whether this parameter changes, all that kind of stuff. It's something that, I mean, it's very related to what Stephen was talking about earlier. It's a very hard thing to do. I think my advice is there's two main pieces of advice, really. I think number one, and this is again another talk, use Scrum and use Agile to have better conversations about no. Have a roadmap that helps people to know where you're going so they can see what they're losing by having you run around like a headless chicken doing operational stuff. And I think that probably the biggest one, which is very unhelpful because we're not really in charge of this, is work in a sane organization. The organization I work in is very sane. They value careful, controlled, proper work. It's very, very, very hard to do your job properly if you're not in an organization like that. I know that's not very good advice, because what do you do about that? Perhaps I'm talking to people who might be able to influence those who are behaving in that way, to understand what they're losing. This constant rush for operational results really hobbles us in the long run. It really stops us from investing for the future, and I think that's a real shame. And I think we all need to talk about that and kind of stand up for ourselves.
Brilliant, very good answer to that question. So yes, in interesting times, we'll move on to our next speaker. Thanks very much again, Chris. That was a really interesting piece of
Thanks,
work.
everyone.